this is the assembly so far. 3 pulleys set up in 3 planes. They are already aligned, but to align them, just make sure the grooves where the rope passes line up between the pulley. To start to make a guideline for the path of the rope, click Insert Component, New Component, then select a plane. We're going to change the sketch to a 3D sketch because it's going to be a 3D guide. I already have planes set up in the center of all the pulleys. So we're going to start by drawing a circle and make the radius 48 millimeters, which will make the circumference the length of the center line down the groove of the pulley. Next, draw some tangent lines off the appropriate edges of the circle. Flip views and select the next plane. We're just going to repeat the steps for the 3 pulleys. When drawing the tangent lines, it doesn't really matter if they meet up because we are just using them as a guide for the rope. Now that we're done drawing all the lines, we're going to hide the pulleys to make it easier to trim. Trim off the extra circular area that does not follow the path of the rope. Lastly, just set all the lines to construction lines. Because we want to make a dynamic rope, we need to make the rope out of links. So we're going to insert component, browse for the link component, and put that on the end of the guide. Although not shown, the construction line has been fixed. We're going to mate the vertex of the link coincident with the construction line, and then make the cylinder of the link parallel with that line. Select the link to copy it, and then just paste a bunch into the assembly. The vertices between links coincident again, and we're going to do this for as many links as it takes to follow the length of that guide path. To try and arrange the links around the path, continually fix and float them while moving other links in the right orientation. Now we add a bunch more links into the assembly and assemble them in the same way to finish the length of that portion of the path. see, it does not have to be perfect. Make sure none of the links are fixed before starting the mates with the pulley. To start, we're going to make the links that will remain on the straight portions of the guide parallel with those portions. Do this for all the links that will remain straight. Fix the end link and delete that coincident mate with the guideline. Now we need to mate the links that go around the pulley with the pulley. To start, we're going to mate the cylindrical area of the links with that cylindrical area down the center of the pulley. We're going to mate it perpendicular and also add a distance between the two. It's going to be 32 millimeters, which is that 48 millimeter radius of the center line around the pulley groove minus half the width of the rope links minus half the width of that cylindrical component down the center of the pulley. Looking from the side, you can see that the links do not fully follow that guide path. It's an easy fix. We're just going to fix one of the links that is on the path. It's going to over-define it, but don't worry because it's only temporary. Then move the links onto the path and then float it again. Thing we need to do is create a mate to pair the movement of the rope with the movement of the pulley. So we're going to select one of the edges that is going to be constantly in contact with the groove of the pulley, and then we're just going to lock it to that groove. This is also going to over-define it, so we just need to go back through the mates and delete the other mates that are associated with that link in the pulley. So after deleting that second mate, some more problems arise. So after giving a quick scan through the mates that aren't working, we realize that we just need to float that end link that we fixed previously. Now you should be good to go, so gently pulling on either end will rotate the pulley as well as move that dynamic rope around it. So after adding all the mates to link up the 3 pulleys in the assembly, I'll show you the mates that worked for creating this dynamic rope system. So these are links locked to the pulleys. So the next 4 mates in the list are coincident mates between vertices of links on the straight portions of the guide and the guideline to keep their motion on the line. And then the next 3 are distance mates, again at that 32 millimeters between the center and the links. And then all of the links along the straight portions of the guide have been set parallel to the guide, and their circular edges have been set concentric with one another. And then pulling gently on one end shows movement along all 3 pulleys.